Lesson is lesson 7. This is for year 12 physics, and this one is on projectile motion. So a projectile is any object that moves freely through the air without its own source of power. So a helicopter is not a projectile, neither is an aircraft, because they all have their own source of power. The only force acting on a projectile when you ignore air resistance is the force of gravity. Now, the path taken by a projectile is called its trajectory, and the shape of this path is that of a parabola. Now, the force of gravity causes the projectile to accelerate downwards all the time at negative 9.8 meters per second squared. And the reason I've put the negative sign is because acceleration is downwards, and these are vectors, so I take everything in the downward direction as negative. So here's an example, and these red dots are various positions of a ball that's been thrown up into the air and it falls down. No matter which part of its motion it is in, the force of gravity is always the same size and always acts vertically down. Now, let's look at the velocity of a projectile. A projectile moves in two directions at the same time. So what are the two directions? It is moving forwards as well as upwards for half the time and downwards for the other time. So it has both horizontal as well as vertical motions. Now, the horizontal velocity of a projectile is at a constant speed. This is because there are no unbalanced forces in the horizontal direction. So the equation that you can use is V equals d over t, because that's the equation you use for constant velocity. And this is the diagram that shows constant horizontal velocity. No matter where the projectile is in its motion, it's always going forwards at a constant speed. However, the vertical velocity of a projectile is accelerated motion due to the unbalanced downward force of gravity. So I've drawn a diagram here that shows you the vertical motion of a projectile. And over here, the velocity is a maximum when you throw it up, and it keeps decreasing and becomes 0 right at the top, and then it keeps increasing as it falls down to reach a maximum when it hits the ground. Okay, and because this is a uniformly accelerated motion, in order to solve the vertical components of velocity, we need to use kinematic equations, those 4 equations that you're given. Now, the horizontal distance traveled by a projectile is called the range, and the time taken to reach maximum height is half the total time of flight. In other words, the time taken to go up equals the time taken to fall down. Now, I'm going to solve one problem using half a projectile, that is when something is thrown like that, and then I'll do another video of how do you solve a problem with the whole projectile. So here's a question. A cricket player attempts to hook a bouncer, and the ball leaves the bat horizontally at a speed of 15 meters per second. The ball is struck 1.3 meters above the ground. So what I do is I separate my vertical and horizontal components. So this is my horizontal speed. I found this later on. The vertical height is 1.3 meters per second, and I know at the top the initial speed is 0, and acceleration due to gravity, which acts downwards, is negative 9.8 meters per second. Anything in blue is what I found later on. So for the vertical motion, in order to find out the time as well as the vertical velocity when it hits the ground, we use kinematic equations. So for this one, I use Vf squared equals Vi squared plus 2AD, and I get my final velocity when it hits the ground, and I get 5.05. And then using another equation, I can find the time it takes to go half the distance, the time it takes to fall down. Now for horizontal motion, the time's the same for the vertical and horizontal. So the horizontal distance traveled, or the range, is the horizontal velocity times the time, and I get 7.73 meters. Now, when the projectile hits the ground, it's a combination of the vertical velocity as well as the horizontal velocity. So in order to find the speed with which hits the ground, you have to use your vector triangle. So this is my vertical velocity, this is my constant horizontal velocity, and then I add them both vectorially to get my resultant velocity with which it hits the ground. So using Pythagoras, I get 15.8 meters per second squared as a resultant velocity in this direction, and quite often you expected to find the angle. So using trig functions, I've got tan inverse of 5.05 divided by 15, and I get about 19 degrees, and that's the angle with which it hits the ground.